So now we are going to start a unit 3, that is numerical integration. So suppose if you have a function f and if you have points x0, x1, x2 up to so on xn, and if you operate the function f, then f of x0 is denoted by y0, f of x1 is nothing but y1 up to so on, f of xn is yn. And if you plot a graph, or if you consider the order pair x0 y0, x1 y1 up to so on xn yn, okay. So now this is what graphically it is. So suppose this is point x0 y0, this is your point x1 y1, x2 y2, xn yn. So these are the points which are because of a function f. Now interpolating polynomial is nothing but, or interpolation is a concept where you want to find a polynomial phi of x such that it satisfies through all these points. So that means it satisfies, or it covers all the points which are covered by a function f. So theoretically it can be written as, if f is a function and if you are operating that function f on a point xi in general, then if you have, so you must have a function phi such that if you operate the function phi on the similar value of xi, both the values should be equal, okay. So this is what a interpolation concept is about. So this function which we have found it out is known as interpolating polynomial. So this is interpolating polynomial. Now Newton's formula for interpolation. So our next point is this. So now if you are given certain n plus 1 points, suppose you have x0, y0, x1, y1 up to so on xn, yn, these are given n plus 1 points, and you have to find a polynomial, interpolating polynomial, that is, suppose in general we denote it as phi of x, and Newton's formula, if we denote it as yn of x, then if this polynomial is nothing but a nth degree polynomial. And in order to satisfy that it is an interpolating polynomial, we have to satisfy the condition that y is nothing but equal to yn of x. So y is equal to yn of x, that is f of x, which is equal to y, is equal to yn of x. So for this, let us have values for x, okay. So whatever we take the values of x, it should be equidistant from each other. That means suppose you have x0, then if the distance between x0 and x1 is 0.2, that means if x0 equals to 0, x1 equals to 0.2, then x2 should be equal to 0.4 up to so on 0.6 and so on. So now if you have given points, then xi should be equal to x0 plus ih with a common difference of h. How this formula arise? It is just like x0 is given. To find x1, you have x0 plus h. So this is the formula for x1. Now for x2, we have x1 plus h, and we know that x1 is nothing but x0 plus h. So this will give you x0 plus 2h. So x2 equals to x0 plus 2h. Similarly, x3 will be equal to x0 plus 3h. So here the suffix of x is equal to the coefficient of h. That's why xi equals to x0 plus ih, and this I goes from 0, 1, 2 up to so on n. So this is the basic condition for the values of x. And then if you have yn x as a polynomial of nth degree, then definitely it can be written it as in general terms, it is a0 plus a1 into x1 minus x0 plus a2 into x minus x0 into x minus x1 plus a3 into x minus x0 into x minus x1 into x minus x2 plus up to so on plus an into x minus x0, x minus x1, x minus x2 up to so on x minus xn minus 1. So this is the general formula for yn of x, a polynomial of nth degree. So now we know that the values of y and yn of x should be equal, that is y equals to yn of x. So for, if you consider the first point y0, then y0 should be equal to yn of x0, right? So for this, substituting the value of x as x0 in this general form, we will get the value of yn of x as a0 plus a1 into y x1 minus x0. So it is not x1 actually, it is just x. So a1 into x minus x0, and if you substitute here as x equals to x0, you will get 0 here. Similarly, in the rest of the terms, you will get the values of this x minus x0 as 0. So all the terms vanishes, so you will just get a0. Now if you consider the second condition, that is for y1, then y1 should be equal to yn of x1. So substituting x equals to x1, you will get a0 plus x equals to x1 will give you a1 into x1 minus x0 plus x minus x0, x minus x1. So x minus x1 will give you 0 because x equals to x1. So this will get cancel out. So now finally you will have y1 equals to a0 plus a1 into x1 minus x0. So keeping a1 at one side, you will get a1 equals to y1 minus a0, shifting this a0 to this, upon x1 minus x0. So now if you consider a0 equals to y0, then you will have y1 minus y0 upon x1 minus x0. If you consider the difference between the values of y as delta, so you will get delta y0 upon x1 minus x0 is the difference between two consecutive terms of x. So this will be equal to some h. Okay. So similarly, going in this process, we'll calculate values for y2. So y2 will be equal to yn of x2. So substituting the values of x equals to x2, you'll get a0 plus a1 into x2 minus x0 plus a2 into x2 minus x0 into x2 minus x1, and the rest of the terms will be cancelled out. So similarly, continuing the process, substitute keeping a2 on the one side and rest of the terms on the other, you will get. So now a2 into x2 minus x0 into x2 minus x1, which is equal to now. So now a2 on the one side, so a2 into x2 minus x0 into x2 minus x1. Keeping this on the one side, you will get a2 into x2 minus x0 into x2 minus x1, which will be equal to y2 as it is minus a0 value is y1, sorry, a0 value is y0 minus value of a1 x2 minus x0. So that value is nothing but delta y0 upon h, the value for a1. So delta y0 upon h into x2 minus x0 as it is. So x2 minus x0. Our previous step. Now if you consider this x2 minus x0, then difference between x0 and x1 is h. Distance between x1 and x2 is h. So distance between x2 and x0 will be obviously 2h. So a2 into 2h into distance between x2 and x1, it is simple h, which is equal to y2 minus y0 minus, again difference between x2 and x0 is 2h into delta y0 upon h. So this h will get cancelled. So you will be left with a2, which is equal to y2 minus y1 minus delta y0, and here into 2 upon 2h square. So this will give you y2 minus y1 upon 2h square minus delta y0 upon h square. So solving this for a2, we will get a2 equals to 2 times this. So this will y2 minus y1 minus 2 times delta y0 upon 2h square. Instead of y2 minus y1, we can substitute here a2 equals to 2 times delta y0 plus delta square y0 upon 2h square minus delta y0 upon h square as it is. Now how we can substitute this? Just because if you consider 2 delta y0 plus delta square y0, then you will get 2 into delta y0, it is difference between the next term and y0, so that is y1 minus y0 plus delta into delta y0, so again this is y1 minus y0. So this will give you 2 into y1 minus y0 into delta y1 minus delta y0. So this will be delta y1 is nothing but y1 minus, so y2 minus y1 and minus y1 plus y0. Okay, so this will give you 2 into y1 minus y0 plus y2 into minus 2y1 plus y0, which is equal to 2y1 minus 2y0 plus y2 minus 2y1 plus y0. So now this 2y1 and minus 2y1 will get cancelled. So you will be left with y2 minus y0, which was y0. This was the needed term. So y2 minus y0 is nothing but 2 delta y0 plus delta square y0. So after substituting this, you will get the values as a2, which is equal to, now again solving for this, it is 2 delta y0 plus delta square y0 upon 2h square minus delta y0 upon h square. Solving for this, equating the denominators, you get 2 delta y0 plus delta square y0 minus 2 delta y0 upon 2h square, which will lead you to delta square y0 upon 2h square. So now this can be represented as delta square y0 upon 2 factorial into h square. Okay, so that's the value for a2. So similarly, you can write it for a3 as delta square y0 as it is upon, instead of 2 factorial you have to write 3 factorial, because f x of a is nothing but 3 into h cube. So this, the power of delta will increase, 2 factorial will change to 3 factorial, and h will change, h square will change to h cube. So now similarly for an you will have delta raised to n into y naught upon h raised to n into n factorial. Now we need to substitute all these values of a0, a1, a2, a3 up to so on an in the general form of yn of x, that's the polynomial we had. So we need to substitute in that. What we'll get is yn of x equals to, now a0 value was y0, then a1 value was x minus x0 into delta y0 upon h, value of a2 was x minus x0 into x minus x1 upon 2 factorial into delta square y0 upon h, and this was the value for a2, this was the value for a1. So similarly going in this way, you will get x minus x0 into x minus x1, x minus x2 upon 3 factorial into delta cube y0 upon h cube plus up to so on. Last one was x minus x0, x minus x1 up to so on, x minus xn minus 1 upon n factorial into delta raised to n y0 upon hn. Okay, now there is one substitution, that instead of x you can write x equals to x0 plus ph. Okay, so as we had seen before, xi was written as x0 plus ih. So instead of this, now we will substitute x, value of x, as the initial position, that is x0 plus some variable p into h. So this, after the substitution in this above equation, you will get yn of x equals to y0 plus, now again the difference, that is x minus x0, this will be equal to, now x minus x0 will give you ph. So this is ph into delta y0 upon h. So this h will get cancelled. So you will be left with just p into delta y0 plus again x minus x0 will be again ph, then x minus x1. So this will be as, so if you consider this second point, that is x minus x1, so let us consider here. So suppose x minus x1 is here, so x minus x1 can be written as x minus, adding and subtracting x0, so you will get x0 minus x0 plus x0 minus x1. Okay, so this will be x minus x0 minus x1 minus x0. Okay, so now this is equal to x minus x0 is what ph is, now minus x1 minus x0 is nothing but h. So if we take h common, then you will be left with p minus 1. So value of x minus x1 is nothing but h into p minus 1. So directly substituting h into p minus 1 here instead of x minus x1, you will get delta square y0 upon h square upon 2 factorial plus, going in this manner, instead of x minus x0 you again have ph, then x minus x1 you will be having h into p minus 1. Similarly for x minus x2 you will be having p minus 2 upon 3 factorial into delta cube y0 upon h cube plus, for nth term p minus p into p minus 1 into p minus 2 into up to so on p into p minus n plus 1 into h raised to n upon n factorial into delta raised to n y naught upon h raised to n. So this h will get cancelled in all the sums. So you will be left with is y naught plus p into delta y naught plus p into p minus 1 upon 2 factorial into delta square y naught plus p into p minus 1 into p minus 2 upon 3 factorial into delta cube y naught plus p into p minus 1 into p minus 2 up to so on p minus n plus 1 upon n factorial into delta raised to n y naught. So now this is what we have. So this is nothing but Newton's forward difference interpolation formula. So we'll make use of this formula to find out rest of the formulas. So this is the initial one. So now if you want to find the error which we have involves in this approximation, that means you had a function f and you had another function, interpolating function yn of x. So now the difference between the actual real point of f of x and whatever we had the approximated function or interpolating polynomial we had, so difference between the values of both the function is nothing but the error. So to calculate the error which we had, so y of x minus yn of x is nothing but, so y of x, you know the general formula, that is x minus x naught, x minus x1 up to so on, x minus xn into y raised to n plus 1 of some function of some variable upon n plus 1 factorial. Between the y of x and yn of x, that's the actual function, and the approximated or interpolating function is nothing but x minus x naught into y minus y, x minus x1 minus into x minus x1 up to so on x minus xn upon n plus 1 factorial into y raised to n plus 1 into eta. So now what is numerical integration? So our next point is numerical integration. So in this, as we have seen, if you have a function f and its values are nothing but x0, x1, x2 up to so on xn, and y is another variable which is nothing but the values of a function f at point x, then this can be plotted like this. So if you have x0 which is nothing but some point A and xn which is another point which is B, and you have a function like this. So for this point you have x0, y0, for this x1, y1, x2, y3, x3, y3 up to so on, xn, yn are your points on this graph or this function. Then if you want to find integration, integration is nothing but the area under the curve. Now if you want to find the area under this curve or area under this function, then so these are the points x0, y0, x1, y1, x2, y2, up to so on, xn, yn, and a function is y equals to f of x is given. So if you want to find integral that goes from certain intervals, so suppose if we consider this interval AB, then this is over A to B y dx. Okay, so now if we consider this interval and if we divide this interval into n equal parts, so that the distance between x0 and x1 is equal to distance between x1 and x2 up to so on. So they are equidistant points x0, x1, x2 up to so on xn. Then we have AB as the interval, x0, x1 are the points after the partition. Now xn is given by the initial point x0 plus n times x, as we have seen this formula before. So you can have xn equals to x0 plus n into x. Now the integral I will be nothing but I goes from initial point A, that is nothing but x0, and end point is B, which is in terms of x is xn. So y dx. Okay. So now as we have seen before that this y of x by Newton's forward difference formula was nothing but y0 plus p delta y0 and so on. So using that previous formula in this equation, you will get I, that is integration, is equal to x0 to xn into y x0 to xn of y0 plus p delta y0 plus p into p minus 1 upon 2 factorial into delta square y0 plus p into p minus 1 into p minus 2 upon 3 factorial into delta cube y0 of dx. Okay. So now as we have seen before that x was written as the initial point x0 plus p into h, right? So that was the substitution we used in the previous formula. So with the help of this x, you need to find the value of dx. So for this dx, so after taking derivative, dx will be equal to x0 is constant, so it will get 0. So now h into p into h, so it will be h is constant and p is dt. So now dx equals to h dt. Now substituting this value, you will get I equals to, so instead of dx we have h dt, so we have h as constant, so we will take outside the integral because integral is with respect to p. So integral, now we have to change the limits as well. So if you have x0 in the upper integration, after the substitution you will get value of x is nothing but x0. So now to have the limits of this integration, as we have converted this dx in terms of dt, so we need to find the change in t. So p goes from, so if initial condition was x equals to x0, then substituting here you will get x0 equals to x0 plus px, so you will get value of p equals to 0. So now p goes from 0 to the extreme condition, that is xn. So for this, if you substitute x equals to x0 plus px, so xn equals to x0 plus px. So taking x0 to this side, you will get xn minus x0 equals to ph. Now xn minus x0 is nothing but, from this equation you have xn minus x0 equals to n into h. So you need to substitute xn minus x0 as nh equals to ph. So from this hh will get cancelled. So value of p will be equal to m. So now new limits for the integration are limit from 0 to n, and it is with respect to p. So now other things as it is, so y0 plus p into delta y0 plus p into p minus 1 upon 2 factorial into delta square y0 plus up to so on d of p. Okay, so that this is after the substitution. So now we have to solve this integration. So solving this, h is constant outside, so integral of y naught, so y naught is constant, so y naught into t, and up, so let's see what happens. So y naught into t plus p square upon 2 into delta y naught plus p square into 2p square minus 3 upon 12. So 2p minus 3 upon 12 into delta square y naught plus up to so on. So this is after the integration, and it goes from 0 to n. So after substituting this values, you will get h into y naught into n plus n square upon 2 into delta y naught plus n square into 2n minus 3 upon 12 into delta square y naught up to so on. So taking n common because it's an odd terms, n into h would be equal to y naught plus n square upon 2 into delta y naught plus n square into 2n minus 3 upon 12 into delta square y naught equals to n. So this is the general formula which I obtained from different integration formula.